section 6.3 is on similar triangles. So far, we've learned that similar triangles have to have a congruent side on the other triangle, and their sides have to be proportional. And I want to remind you of when we were talking about, now that's with similar triangles, when we were talking about congruent triangles, if you remember right, we learned shortcuts for congruent triangles. Side, 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 angle, angle, side, and angle, side, angle. Hopefully those seem very familiar to you. And we have similarity shortcuts as well. But there's only 3 of those. There's angle, angle, side, 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 angle, side. So instead of having to prove that every angle has a congruent angle on the other triangle and every side has a proportional side on the other triangle, you can use a shortcut. So let's talk a little bit more about the shortcuts. The angle shortcut says if I have an angle congruent to another angle and another angle congruent to another angle, so I have 2 sides that are congruent from 2 triangles. So this is congruent to this is congruent to that, then I can automatically assume that these 2 triangles are similar. So I can write triangle ABC is similar to triangle EFG, lining up the sides that are congruent. Remember, if 2 angles are congruent on another triangle, then I automatically know their third angles are congruent as well. If I have side, 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 that does not mean that the sides are equal. It means the sides are proportional. So if AB is proportional to DE and BC is proportional to EF and CA is proportional to FD, then I automatically know that triangle ABC is similar to triangle DEF. Now that's like if this was a 1 to 2, this one would have to be a 1 to 2, and that one would have to be a 1 to 2. Or whatever the fraction or the decimal value of this is, it would have to be that. It would also have to be that. So you have angle, angle, and side, side, side. These are similarity shortcuts, not congruency shortcuts. All right, on this one, side, angle, side, I would have to know that, let's say I know that that angle and that angle are congruent. Then I would have to know AB is congruent to DE and BC is congruent to EF. So that would be the 2 sides on both sides of that angle. So side, angle, side, side, angle, side. Now remember, you're not saying that the sides are equal. You're saying they're proportional. So if this was 2 and this was 1, reduced down, this would have to be reduced down to 2 and 1. All right, here's an example problem from this information. Okay, I know that FG is congruent to EG, and I know that BE, which is this whole measurement here, is 15, and CF, which is this whole measurement here, is 20, no, yeah, well, that doesn't sound right, 20, and AE is 9, and DF, so that's this one, and DF is 12. Obviously this is not drawn to scale. Determine which triangles are similar. So I look here, and I can go, well, is 15 proportional to 20 the same way that 9 is proportional to 12? So 15 is on this triangle, 20 is on this smaller triangle, and then 9 is on the bigger triangle, and 12 is on the smaller. Believe it or not, that is a illustration that they have drawn out, but it can't be drawn to scale. So I want to figure out if these two triangles are similar. So I go 15 divided by 20. That gives me a 0.75. 9 divided by 12 gives me a 0.75. So I'm looking at these and I'm going, okay, so I have two sides that are proportional. Do I have angles that are congruent? I do, because this angle on this small triangle has to be congruent to that angle on the large triangle, because angles opposite congruent sides are congruent. So I just proved that these two triangles are similar by side, angle, side. And I can say F triangle FCD is similar to triangle EBA. All right, let's look at another one. We've got two sides that are parallel, so you can better be thinking alternate interior angles. I can go ahead and mark those. If that's parallel with that, then I know that this angle is congruent with that angle, and I know that this angle is congruent with that angle. Okay, I also have lines that are marked congruent, which means I can also say sides opposite are congruent, and sides opposite are, or angles opposite the sides are congruent. So if you look at this, I could already do these two triangles because I already have two angles. So I already knew the third angle was going to be congruent. So I can say triangle, and I don't even have to deal with any of these, okay? Because I have angle, angle. So I can say triangle ABE is similar to triangle CDE. And I did that by angle, angle. I actually have all three angles. All right, you're going to use similar triangles to solve for unknowns. So it's asking me to solve for AE and for DE, which means I'm going to have to solve for x minus 1 and x plus 5. So I got to know what x is. This is parallel to this. So that and that have to be congruent because they're alternate interior angles. I also know these two have to be congruent because those are vertical angles. So therefore, I can go ahead and know for sure that those are congruent. So I'm going to go left triangle, right triangle, and I'm going to set up a proportion problem. So between 1 and 3 on the left is 2. Between 1 and 3 on the right is 5. Between 1 and 2 on the left is x minus 1. Between 1 and 2, I mean these little semicircles, if you will, the curves, is x plus 5. So I'm going to cross product, and I'm going to have 2 times x plus 5 equals 5 times x minus 1. So 2x plus 10 equals 5x minus 5. And I have to solve for my x. So I'm going to subtract the 5x, and I'm going to get a negative 3x. Subtract the 10, I get a negative 15. When I divide by negative 3, I get x is equal to 5. But that's not what it asked me for. It asked me for AE, so I have to plug it back in. And I find out that AE, which is x minus 1, is equal to 4. And DE, which is x plus 5, is 10, because I have 5 plus 5. All right, let's do another one of those. Again, you've got parallel lines. And then they give you some other measurements that you've put on the figure already, and they're asking you to find RQ and QT. All right, so I'm going to mark angles that should be congruent. Let's see, this and this are alternate interior angles. Those two are vertical lines, and those two would have to be congruent as well. So left triangle, right triangle. Between the 1 and the 3 on the left is 10. Between the 1 and the 3 on the curves, if you will, hopefully you understand what I mean by that, is 4. Between the 1 and the 2 little curve marks is 2x plus 10. And between the 1 and the 2 here is x plus 3. So I'm going to cross product. So I have 4 times 2x plus 10 equals 10 times x plus 3. 8x plus 40 equals 10x plus 30. I'm going to subtract the 10x, so I have a negative 2x. I'm going to subtract the 40, so I have a negative 10. When I divide by the negative 2, it's going to give me x is equal to 5. Then I have to plug back in. RQ is x plus 3, so it's 5 plus 3 or 8. And QT, which is this, is 2 times 5 plus 10, so that's going to be 20. Hopefully you were able to see that from beginning to end. All right, your homework on this is page 302, 10 through 20 even, and then 29.